Now, my dear friends, we can see the haloalkanes and haloarenes. This is a crash course, and in this crash course, you can get in this unit. We can discuss the all questions which are asked in NEET exams, so you can improve your learning skills as well as you can attempt the questions which are asked in your exams. Now, my dear friends, we can see the concept in each questions. So, we can go to the first question that is asked in 2015. My dear students, in this question, the reaction of CH5CH double bond CH3 with HBr produces. Here, my dear students, this question asked in 2015 NEET exams. But this exam is how cancelled. My dear students, here, this concept of this question, what is the concept of this question? You can see here the reaction. Here CH5CH double bond CH3, you can write in this way, C6H5 CH, this is the double bond CH, and you can write here CH3. Here, my dear students, when you can add this HBr, and what is the product? Here, my dear students, HBr, H plus ions and Br minus ions are present. Electronegative part is attached to that carbon atom in which low number of hydrogens are present. Now, here question is that these pi electrons move in this side or in this side. Here, my dear students, you can see here these pi electrons are moved from in this side. Why? Because here resonance is occur, and due to this resonance, this benzening is a partially electropositive in nature. So, my dear students, these benzenes accept the lone pair of electrons. So, these or attacks the lone pair of electrons or bond pair of electrons which are present between this carbon and this carbon. So, my dear students, this benzening attacks this lone pair of electrons which are present between the carbon and carbon atom. And this alkyl group repel the bond pair of electrons in this way. These electrons go on this carbon atom and negative charge present on this carbon, and you can see here positive charge is present on this carbon atom. Now, my dear friends, this electron negative part of bromide, it is attached on this positive charge of this carbon atom. So, my dear students, here when this electronegative part attached on this carbon, you can see, you can get this structure here CH negative and here CH, Br and CS3. My dear friends, this Br negative ions neutralize this positive charge of carbon atom. So, Br anions or bromide anions added with this carbon atom, and final this H plus ions attach this carbanion ions. So, you can get the product, and your product is this one CH2, CHBr and CS3. So, this product is present CH5, this is CH5, CH2, this is CH2, CHBr and CS3. So, my dear students, you can go the question number 1, and this is this CH5, CH, Br, CH2 and CS3. Now, my dear students, here you can see when you can added this bromide ion Br minus in this side, and this is the CH. Here you can see this is stable or not. First of all, you think this anion is stable or this anion is not stable. My dear students, when this carbocation is present, carbanion ion is present in this side, this is stable or not, you can see or you can think this. My dear students, when you can form this compound in this anion, in this way, we can form this another anion. This CH2, this is CH, so we can form this CH, not CH2, here CH, and this electrons go to this type CH, so CH negative and positive is present on this compound, positive ion. This positive charge is present on this side. So, my dear students, you can see here CH plus and CH3 minus. Here, when electron go to this carbon atom, then this anion is formed. And when you can see this anion, carbanion ion is present on this carbon and positive charge is present on this molecule. Now, we can see this is the number 1 molecule, you can here write, and here you can write here number 2 molecule. Now, my dear friends, you can compare with this which molecule is more stable. Here CH plus molecule or here CH minus molecule, which molecule is more stable. Here, my dear students, when you can go to this CH plus molecule, this is the benzyl carbocation. You know this is a concept, my dear students. Concept is this: benzyl carbocation means CCH5 CH2 plus is always more stable than CH2 double bond CH and CH2 carbocation, and it is more stable than tertiary carbocation. It is more stable than secondary carbocation, and it is more stable than primary carbocation. My dear students, when stability order is this one, this is the stability order. This is the stability order of carbocation. Secondary carbocation is more stable, or this benzyl carbocation is more stable than allyl carbocation, and allyl carbocation is more stable than tertiary. Tertiary is more stable than secondary, and you can see here secondary is more stable than primary carbocation. It shows that, my dear students, this benzyl carbocation is more stable than this carbanion ion. When, my dear students, when this carbanion ion is less stable, why this compound, why this product is formed? Because this is less stable. This carbanion ion is less stable. So, my dear student, this is less stable and this is more stable. So, carbocation is more stable. So, this Br minus ions go to the more stable carbonium ion. Then this less stable double bond CH plus and CH3. This part is less stable. This part is also less stable than this part. This part of the molecule is more stable. So, my dear students, reaction is go in this level. This is, you can form the CH plus, CH minus and CH3 and reacts with this HBr. Here no reaction take place here. Here HBr, Br minus and H plus ions. So, you can go down, my dear students, bromide ions not attached by this, it is attached by this CH plus ions. And when this is attached by this CH plus ions, my dear students, compound is formed, that is CH, Br and then CH minus. It is minus is converted to H plus ions, it is converted to CH2, CH3. So, you can go when you can go the answer D, When this is stable, then you can form this answer. But my dear student, this is not stable. Stable cation is the benzyl, and we give you concept. Benzyl carbocation is more stable than it is called allyl carbocation. So this is benzyl carbocation. So my dear students, you can get this compound here, and you can go the answer C. So my dear students, question number 1, correct answer is C. Now my dear students, we can go the question number 2. Here my dear students, question number 2, you can get this. This is the, what is the reaction and concept. Here my dear students, when we see the reaction and concept, what is the reaction and concept? Here my dear students, reaction and concept. You can see here this Ci reacts with here metal fluoride. Which metal fluoride is displace this iodide ions? This is the question. Here my dear students, when this metal, you can see the options. The reaction will be most favorable if M happens to be metal is sodium, potassium, rubidium or lithium. My dear students, here when this sodium is formed, this is NF. For rubidium it is RBF, and for this potassium you can get the KF, and for lithium you can get the lithium fluoride. Here my dear students, concept is that when you can go to the top to bottom, lithium, sodium, potassium, rubidium and cesium. Here this reactivity increases. So my dear students, here sodium is less reactive than potassium, here potassium is less reactive than rubidium, and rubidium is less reactive than cesium. So my dear students, when rubidium fluoride reacts with this compound, then this compound is easily replace the iodide ions, and here you can see compound is formed CF plus Mi compound. So correct answer is your C, because rubidium is more reactive than potassium and sodium. So when rubidium fluoride is reacts with this iodide, alkyl iodide, to form this alkyl fluoride plus rubidium iodide. So my dear students, when you can see the reactivity series in first A group elements or S block, then you can see the reactivity is increases. So rubidium is the correct answer here. Now my dear students, when we see the question number 3. In question number 3, my dear students, when chlorine is passed through propene at 400 degrees Celsius, which of the following is formed? What is the reaction and concept? Here my dear students, this propene is the CH3, single bond CH, double bond CH2. This compound is called propene because 3 carbon atoms are present and 1 double bond is present between carbon and carbon. So my dear student, it is called propene. When this propene reacts with chlorine, this chlorine gas at 400 degrees Celsius, and this chlorine gas is heated, this replaces this hydrogen atom and form, my dear students, CH2Cl, CH double bond CH2. My dear students, concept is that at high temperature, chlorine show substitution reactions substitution reaction, in place of addition reactions. Here, my dear students, you can see here at high temperature, chlorine show substitution reactions in place of addition reactions. So, this hydrogen is replaced at 400 degrees Celsius and you can get the CH2Cl, CH double bond CH2. My dear students, it is called allyl chloride. This compound is called allyl chloride because, my dear students, allyl group is the CH2, single bond CH, double bond CH2. This group is called allyl group. So, you can see here this is called allyl chloride. So, you can go to the B option, question number 3, that is B option. Now, my dear students, we can see here question number 4. Here, my dear students, in question number 4, elimination reactions of 2-bromopentane to form pent-2-ene is. Here, my dear students, first of all, you write reaction and see the concept. 5 carbon atoms are, you can structure of 5 carbon atom because here pentane, 2-bromopentane, 1, 2, 3, 4, 5 carbon atom, it is called pentane, and bromine group is attached on second carbon atom. That is why you can see here CH3, CH3, CH2, CH2, CH and CH3. This is called, my dear students, 2-bromopentane. 1, 2, 3, 4 and 5. It is called, my dear students, 2-bromopentane. And this 2-bromopentane is converted into pent-2-ene. 1, 2, 3, 4, 5. Here it is called pent-2-ene, means double bond is present, second carbon atom. So, it is converted to CH3, CH, CH, CH2 and CH3. Here, my dear students, it is called pent-2-ene because double bond is present on second carbon atom. That's why it is called pent-2-ene. Here, this is the elimination reactions. You can see here, this is the elimination reactions because in this reaction, my dear students, halogen is replaced as well as this hydrogen atom is also replaced. So, this reaction is occur in presence of alcoholic OH. When you can hit this alcoholic OH with this compound, then this halogen is replaced by this potassium minus KBr, and this hydrogen atom is also replaced by this water molecule. Now, my dear students, here in this elimination reaction, question is that this is beta elimination. Yes, this is correct. It is a beta elimination. Why? Because, my dear students, this is the function group. This carbon atom is alpha, and here you can see the beta hydrogen atom is replaced in this product. When this product beta hydrogen atom is replaced, so you can get the CH3CH, double bond CH, CH2, CH3. My dear students, in beta elimination, you can get the CH3CH2CH, here CH3CH2CH, double bond, here CH3. Numbers 2, follow Zetschrift or Zetschrift rule? Yes, because, my dear students, according to Zetschrift rule, that alkene is more stable in which more number of alkyl groups are present. Here you can see the more alkyl groups are present, CH3 and CH2CH3. Or you can say that those alkenes are more stable in which more alpha hydrogen atoms are present. So, you can see here 3 plus 2, 5 alpha hydrogen atoms are present. So, it follows the Zetschrift rule. Now, my dear students, see, it is dehydrohalogenation reaction. Yes, my dear students, because removal of hydrogen and removal of halogen is take place. That's why, my dear friends, it is called dehydrohalogenation reaction. My dear friends, in this way, we can see here A, B, C are the correct answer, and option, that's why option A is the correct here, A, B, C. My dear friends, here D option is not correct because dehydration is known as removal of water. What is a dehydration? My dear friend, removal of water is called dehydration, and this dehydration is not take part in this reaction. Removal of water is not take part in this reaction. So you can see here dehydration is not take place. So my dear students, you can see here in this section option is A, B and C. The hydrolysis reaction that takes place at the slowest rate among the following is. What is the concept of this question, my dear students? You see the concept of question. Concept is that that of these reactions. In this, those reactions are more reactive in which cations are more stable. When you can remove this cation from this Cl minus ions from this aqueous NOH. Aqueous NOH means this is the base, my dear students, and this base when reacts with this halogenated compound, then you can get this carbocation. Here, my dear students, this carbocation is stable. When this C part, you can remove this Cl minus ions and form this cation. This cation is present in the resonance because this electrons, pi electrons go inside CH2 and this cation in this cation is present in CH plus ions. It is converted to cationic form, and this resonance is also placed in this form, and this cation is present in this CH2 group. In this way, my dear students, this cation is stable. Stable cation, it means more reactive. Now we can see here, when this Cl minus ions is removed, you can get this benzyl cation, and my dear students, we can see this benzyl cation is most stable, so it is most reactive. So rate of reaction is fast. When you can see the rate of reaction in this, it is CH2 double bond CH and CH2. This is the rate of reaction is also fast, but it is slow than this compound benzyl carbocation. Now we can see the primary carbocation CH3CH2 plus charge. Here you can see this is a less stable, but this is more stable than this cation in option A. Here you can see in option A, Cl and carbon atom. Here this single bond is also converted to double bond, because this chlorine atom accept these electrons, my dear friends, and these electrons are resonating electron with this chlorine atom, or lone pair of electrons of chlorine also present in a resonance form in this benzene. So my dear friends, here between the carbon and chlorine, double bond character is also present, and due to this double bond character, this carbon chlorine bond is not so, this carbon chlorine bond is so strong, it is not easily broken. So my dear friends, when this aqueous NOH reacts with this compound in which chlorine and carbon is present, so this bond is not broken, so reaction is slow. This is the concept of this reaction. Carbon chlorine bond, double bond character is present, double bond, we can write here in this way, in carbon and chlorine, double bond, character is present, double bond character is present. So, it is not easily break. Hence, reaction is slow. So, my dear students, in question number 5, answer is A. Now, my dear students, question number 6, we can go to the question number 6. And in question number 6, what is the reaction and concept? Reaction. This question is also asked in NEET 2018. My dear students, compound A reacts with sodium to give compound B. B is reacts with PCl5 to compound C. This is our first reaction. When this B and C both are reacts to form diethyl ether. This is our second reaction. Here, my dear students, what is the compound ABC? This question is asked in NEET 2018. Now, we can discuss here. Diethyl ether is formed by sodium ethoxide and ethyl chloride. So, it must be B is the sodium ethoxide and C is ethyl chloride or vice versa. My dear students, here you can react with this PCl5. Means C must be C2H5Cl, because when this PCl5 reacts with B to form C2H5Cl and this C2H5Cl is reacts with B, it means B must be sodium ethoxide. Now, this sodium ethoxide is reacts with A compound. When this A compound is reacts with sodium to form sodium ethoxide, it means A must be ethanol. Because, my dear friends, when this ethanol is reacts with this sodium metal, here this is a sodium metal, reacts with this ethanol to give sodium ethoxide. And this sodium ethoxide reacts with PCl5 to remove this as a POCl3 and HCl and form, my dear friends, C2H5Cl. So, this is the reaction, because C2H5ONA, when this reacts with C2H5Cl to remove this NaCl and form diethyl ether. So, my dear friends, you can go the answer D. Here, my dear friends, answer D. A is the C2H5OH. Here, when you can see the B, that is C2H5ONA. When you can see that this C, it must be C2H5Cl. So, you can go the option D. Now, my dear friends, question number 7. It is also asked in 2018 NEET exams. The compound C7H8 undergoes the following reactions. C7H8 reacts with TriCl2 to give A. A is reacts with bromine and iron to give B, and B is reacts with Zn and HCl to give C. My dear students, it's a very basic questions and very important questions. My dear students, you can see the reaction and concept. Here reaction C7H8. What do you mean by C7H8? My dear students, it must be benzene. Why? Because, my dear students, benzene CCH6 is present and it must be one hydrogen atom is replaced to give C6H5 and one carbon atom is attached, and when you can attach this CH3 group, my dear students, then you can get the molecular formula of C7H8. So, C7H8 nothing, my dear students, it's a toluene. C7H8 is a toluene. Now, we can start the reaction. This toluene reacts with TriCl2 and heat. So, when Cl2 is heated, then substitution reactions take place. So, my dear students, here you can get the CCl3 compound. Here, my dear students, this is the CCl3 compound, and this CCl3 compound, when reacts with this is the A compound, reacts with this bromine and iron. No doubt, In iron, my dear students, this FeBr3 is formed, bromine reacts with iron, then FeBr3 formed, and this FeBr3 is act as a loose acid. Means this loose acid further reacts with bromine and to produce this bromonium ion. So, my dear students, you can get the bromonium ions from this solution of iron with bromine liquid. This bromonium ions is electrophile. So, my dear students, this electrophile is attack on the benzening of this compound. Now, this is attack on this benzening of this compound. It is called electrophilic substitution reactions. And so, you can get the electrophilic substitution reaction CCl3. Now, my dear students, CCl3 inductive effect is occur. So, my dear students, you can see here this CCl3 Br is attached on meta position. Why? Because it is a meta directing group. My dear students, when it is a meta directing group, so it is present in meta position bromo. Now, when we take the Zn and HCl, in the presence of Zn and HCl, it is the presence of Zn and HCl. My dear students, here this reduction is take place and all the chlorine atom is removed by the hydrogen atom and you can get the CH3 group. So, my dear students, CCl3 is converted to CH3 further by the reduction of zinc and HCl. So, this compound is called meta-bromotoluene. After this compound is a C compound, this compound is a B compound and this compound is a compound. So, my dear students, you can get the meta-bromotoluene and this question is asked in NEET 2018. We give you reactions and concept. Now, my dear students, we can go to the question number 8. Here, my dear students, this question is asked in NEET 2017. Identify A and predict the type of reactions. Here, my dear students, here NaNH2 is attack on this compound. My dear students, it's also very important reactions. Here, my dear students, this is a methoxy group and this is the Br. My dear students, methoxy is a electron donating group. It donates the electrons to ortho and para position. So, my dear students, in ortho position and para position, electronegativity is increases and this Br attacks this electrons. Here, when this NaNH2 is reacts, you can see here sodium is present cation form and NH2 is present in anion form. So, my dear students, here this NH2 is attack on NH2 minus is attack on this H plus ions. This H plus ions is present in hydrogen because this carbon atom is electronegative in nature due to this donation of this oxygen lone pair of electrons. Here, my dear students, when this NH2 minus ions is attack this H plus ions, at that time, here you can see this bromine is given the accept the electron and give the bromide ions and or convert into bromide ions. Now, this ring, my dear student, this is the benzening. Now, this benzening is converted into benzene ring. This is called benzene ring. Because here bromide ions is left, here H plus ions accepted by this NH2 group and it is replaced. So, it is called benzene ring. And due to this benzene ring, when negative charge is here and positive charge present here, then this positive charge, this NH2 minus ions attack on this positive charge. And my dear students, it is convened to OCS3 and this NH2 group. Now my dear students, this negative charge present on this carbon atom, so it accepts this H plus ions and form this compound NH2 and OCS3 group. So my dear students, here you can see here NH2 group is present, but you can see this is this electron present in this side or in this side. Here this is the main problem, because this benzene group go to in resonance. So resonance is occur, and when you can go this side, in this equation, in this direction, you can get this ortho NH2 group is attached on this ortho position, OCS3. And you can go this compound is formed. Here my dear students, when this compound is formed, here you can see here elimination and addition reactions are present. Here my dear students, elimination reaction is not occur, so this reaction is not there. Now we can see here, this is resonance is present in this compound, plus and minus. Here my dear students, this you can see the lone pair electrons go in the ring, and this is a ortho and para group, electron density is maximum. So my dear students, benzene, this resonating structure of benzene is more stable, in which negative charge present on this positive charge present on in this side and negative charge present on in this side. So my dear students, it is more stable, this benzene is more stable, this benzene is more stable and it is a less stable. Because my dear students, it is a less stable and it is a more stable, so when this more stable benzene, this NH2 group is attack on this carbon atom. So my dear students, main product or major product you can get, this NH2 group is attached on this meta position. And here you can see this NH2 group is attached on this meta position, bromide ion is replaced. These are present in the mechanism, this is called mechanism, and not happened due to less stable benzene group. Less stable benzene group. So my dear students, your correct answer is this, and you can go to the answer D, question number 8. It's a very important reaction, because in this reaction you can see here benzene is formed in mechanism, and substitution is occur because this bromide ion is replaced by this NH2 group here in same position. So my dear students, it's called substitution reactions. In elimination reaction, you always know that in product extra double bond is present, but you can see in this product extra double bond is not formed, so elimination reaction is not occur. Now my dear students, we can go the question number 9. Consider the reaction CH3CH2CH2Br plus NaCN to give CH3CH2CH2CN plus NaBr. The reaction will be first as in this reaction, my dear students, it is a SN2 type reaction, because here you can see this carbon atom, number 1 carbon atom bromide is present, and this is the number 1 carbon atom. Here you can see the cyanide group is attached with the replace of this bromide group. So my dear students, this type of reaction in which carbocation is not formed, this type of reaction are called SN2 type reaction. So my dear students, it's a SN2 type reaction. And in SN2 type reaction, my dear students, you can see here in SN2 type reaction, number 1 point. Number 2nd point is in SN2 type reaction, my dear students, here this reaction is fast in the same polar aprotic solvent. When you can take the polar aprotic solvent, then it's favor the SN2 type reactions. And my dear students, here you can see the SN2 type reaction because here carbocation is not formed. Carbocation is not formed. So this reaction is called, my dear students, so this reaction is called SN2 reaction. SN2 reaction. You know very well in haloalkanes, haloarenes, you can learn this SN2 reaction, my dear students. And in SN2 reaction, carbocation is not formed, only tension state is present. 4th point, in SN2 reaction, transition state is present. Here, my dear students, in this question, you can see the tension state because this cyanide ions, first of all, attack on this carbocation. So you can get the tension state, and after this tension state, you can get this compound. So you can go answer D, answer C, 9th answer C, my dear students, because this is polar aprotic solvent, but is a N and dimethyl formate. Here, my dear students, you can see the structure. This structure is for N and dimethyl formate SCO, and here you can see the 2-methyl group. So you can call this methyl group is attached with this nitrogen atom. So it is called N-methyl, and here it is called N-methyl. So it is called N and dimethyl formamide. Short form of this compound is called DMF. D for di, M for methyl, and F for formamide. So my dear students, it is also called dimethyl formamide. This question is asked in NEET 2016. I hope I give you concept of this question. How can this solve these questions, and you can learn, my dear students. My dear students, in question number 10, which of the following biphenyls is optically active? What is the concept of this question? You can see here, this is the ortho position of the biphenyls here. But here ortho position of biphenyl, here you can see only one iodine is present in ortho position. Here only one iodine is present in ortho position. That's why it is a symmetrical compound, and when symmetrical molecules are present, it is not optically active. Means we can see, number 1 point, we can see molecule is unsymmetrical, then this molecule show optically activity. It must be, molecule must be unsymmetrical. Here, my dear students, this molecule is symmetrical because in ortho position only one substituted groups are present. Here, my dear students, in B option, only one benzene in biphenyl, 2 ortho substituted are present. So it is also a optically symmetrical. When you can see, when you can cross in this plane, you can get same part. So it is called optically active. My dear students, when you can see here, this compound is optically active because when you can when you can part or divide it into two parts in this plane, then you can get here two symmetrical point. So it is also optically active. But in option D, this is optically inactive or optically active. This is optically inactive. This is optically active. Why? Because, my dear students, you can get two different substituents on ortho position in one phenyl group. Here, my dear students, you can get two different groups which are present on carbon atom on phenyl groups on ortho position. Means second point is that in biphenyls are optically active when two substituents are present on ortho position are different, then molecule becomes unsymmetrical and show optical activity My dear student, this is the concept of this questions, and this question now we can go to answer D, because here you can see the two different groups are present on ortho position and both are different. So when two different groups are present, you can part of these groups, you can see the different plane. In different plane, you can not get the same part in any side. So this is optically active compound, and this question is asked in NEET 2016, my dear students. Now we can go to the question number 11. Here, my dear students, in question number 11, we can see what is the answer. You can see easily this question. It's a very easy question, my dear students. In the following reactions, here number 1, CH3, CH2, CH2, Br plus KOH, CH3, CH, double bond CH2 plus KBr plus water. Now question is that which of the following statement is correct? A is elimination, B and C are substitution. First of all, you can see this elimination or which reaction these are. My dear students, A, you can see in product double bond is formed. When double bond is formed in the product, then my dear students, it is the elimination reaction. So here this A is the elimination, it is not substitution. This is elimination, here elimination. Now we can go to the B reaction. Here B reaction, you can see the reactant product. This Br is replaced by this OH minus ions. So you can see here, this is the substitution reaction. B is the substitution. Here B, option A substitution. Here B is addition, so it is wrong. Here B are elimination, so C is also wrong, because B is also take as elimination, but B here is a substitution because double bond is not present in a product. Now we can see D option, A is elimination, B is substitution, it may be answer. Now we can see the C option. Here C reaction, Br2 is added in this carbon atom and in this carbon atom. So my dear students, when this Br is added both carbon atom and double bond is broke down and it is converted to single bond, so it is called addition reactions. So A is elimination and B is substitution, C is not substitution, so A option is wrong. Here you can see B wrong, C wrong, and D option, A elimination, B substitution, C is addition reaction. That's why you can go the option D. 11th correct answer is D. This question is asked in NEET 2016, my dear students. It is a type of reactions, elimination, substitution.